exponential function. Okay, let's review. So this pair 1, 2 corresponding to a point. Let's draw the point. Go right 1, go up 2. Okay. Now this point 2, 4. This one corresponding to 0, 1, which is this point. Now let's plot another one. How about -1, 1/2? Okay, this is a graph of this exponential function. Similarly, let's try this one. This pair 2, 1 corresponding to a point 2, 1. Now this one 4, 2. Go right 4, go up 2. Okay, let's try this one. 1, 0. Let's try one more. How about this one? 1/2, -1. Okay, now let's get to the graph of this one. As we can see from the graph, these two graphs, they are mirror image of each other across the line y = x. Is that right? Very good. So let anybody know why is this? So recall the first section of this chapter, we studied inverse function because these two are inverse function of each other. Okay. Now let's start with some example. If possible, find the following number. Let's do this one together. We want to find the number logarithm base 2 of 8. Okay, let's think about how can we solve this one. Suppose we call this number is y. Okay, now we have the logarithm form. Let us change this logarithm form into exponential form. So remember, you're going to put a base here. They are inverse function of each other. Then we switch the input and output. So change into exponential form, put a base 2 here, switch the input and output. Okay. Now let's think about 2 to which power is 8? Does anybody know that? 2 to which power is 8?
3.
Very good, okay. 2 to the third power is 8. So y is 3. Okay, very good. Now let's try another one. How about logarithm base 2 of 1? Okay, let's think about it. So we can approach this one similarly. suppose this number we're looking for, suppose it is y. Okay, we can change this into exponential form. So how to do that? Put the base here, then switch this to input and output. Put the base here, switch this to. Okay, write into exponential form. Everybody get this part? Write into exponential form? Okay, very good. Now let's think about it. 2 to which power is 1? As we can see, anything to the 0th power is 1. Okay, let's go back and look at this table. As we can observe here, to the 0th power is 1, so logarithm are exponent. Logarithm base 2 of x is the exponent that we need to raise the base 2 to in order to get x. Okay? Now I'm going to give you guys one problem to try. Now you guys try this one. Okay, try to find this number. I'm going to give you guys 1 minute to work on this one. So remember, negative exponent we're going to put in the denominator. Okay, very good. Okay, now let's do this one together. So most of you guys did able to figure out. So suppose you call this guy is y. Let us write into exponential form. So put the base here, switch this two. Now 1/3 we can rewrite as 3 to the -1 exponent. Okay. So what should y be? Anybody could tell? What is y?
-1.
Very good. Okay, now we have used this definition to find the number. Now another type of exercise, we're going to solve equation that involves logarithm. For this, we're going to use the following fact. We have the following fact. So this fact tells us logarithm base A of x1 equal logarithm base A of x2, then x1 equal x2. So we can get rid of logarithm if two sides have the same base. Let's think about why is this. The reason is the following. We can suppose this is y. Let's change this into exponential form. If we cover the middle part, okay, let's look at this one. Let's change this into exponential form. So put a base here, then switch the input and output. Similarly, let's look at this part. Let's change this into exponential form. We're going to put a base here, switch these two. And now let's use this fact to solve the equation. Okay, let's try this example together. Suppose we have the following equation. Let's solve this equation together. For this one, we're going to use this fact. We can directly apply the fact. These two have the same base. We can get rid of the logarithm. By the fact, we have the following. Then we can solve this equation. Let's subtract 2x on both sides. Now 2x minus 2x cancel. Left hand side equal 2x minus 5. Right hand side is 1. Now let's add 5 on both sides. Now let's simplify. Minus 5 and 5 cancel. Now let's divide 2 on both sides. 2 is not equal to 0. We can divide 2 on both sides. Okay, this is our solution. Now let us check our solution. So when x equals 3, left hand side of our equation, I'm going to plug in 3 into the left hand side. Now let's simplify. 4 times 3 is 12. 12 minus 5 is 7. Agree? Okay, very good. Now similarly, right hand side equals this. Now let's simplify. 2 times 3 is 6. 6 plus 1 is 7. So they are equal. So this number is a solution. Okay, very good. Now this one we can directly apply this factor. Now there is another type of logarithm equation. Let's try one together. Okay, suppose we have the following equation. Think about how to do this one. Let's think about it. How did we do the first one? So remember, we did the first one by change this form into exponential form. So similarly, we can change this form into exponential form.